Suppose I did a study comparing two different teaching strategies, wanted to use the final exam grades to compare the effectiveness of each. This is an example of testing two sample means. We're going to explore comparing two independent means with the two sample t interval in this lesson. So comparing two independent means is very similar in comparing two independent proportions, which we developed earlier. And just as we added variances with proportions, we do the same thing for means. Recall that our general form is statistic plus or minus margin of error. And this can be broken down further as statistic plus or minus critical value times standard deviation of that statistic. Our one sample t interval was given as x bar plus or minus the t critical value times standard deviation over the square root of n. So the difference of two independent means will be x bar sub 1 minus x bar sub 2 plus or minus the test statistic t star times the square root of s1 squared over n1 plus s2 squared over n2. Again, the variance of the difference is the sum of the variances. So see how this was developed in the 2 prop z interval and or in the reading. And degrees of freedom gets a little tricky. We can either use the smaller of n1 minus 1 and n2 minus 1, or we can use technology. So note, there's actually a pretty scary looking formula to compute this, but it's beyond the scope of this course. Also, as usual, we do have some conditions, and the same ones we've been using all along. So the data from each group should be independently drawn or part of a randomized experiment. They should be simple random sample. They should also be independent groups. You could not have husbands in one group and wives in another, for instance. Can't be larger than 10% as usual. And if the samples are small, so less than 30, you should verify that they could have come from a normal population with histograms, box plots, check for outliers, and stuff like that we've been doing all along. Let's do an example, and we're going to do two examples. The first one will be done via the formula and technology, and the second one will be done just with technology. Example 1. Each year, the U.S. Environmental Protection Agency releases fuel economy data on cars manufactured in that year. So below are summary statistics on fuel efficiency in miles per gallon from a random sample of cars with manual and automatic transmissions manufactured in 2012. Do these data provide strong evidence of a difference between the average fuel efficiency of cars with manual and automatic transmissions in terms of their average city mileage? So we're going to run a 95% confidence interval and interpret. And let's assume that conditions for inference are satisfied. So it says that conditions were satisfied, and this problem provides the box plot. We would not be able to really determine this easily without this because we're not given the raw data. When you're just given summary statistics, they'll often say something like this in the problem, or they'll provide some of the visual displays. So we're first going to compute this using the formula. So we're going to call automatic sample 1 and manual sample 2. And this is completely arbitrary. We could have flipped those. And since both samples are n equals 26, our degrees of freedom, 26 minus 1 is 25. If there were different samples, remember we take the smaller of the two. So we look this up in the table. Degree of freedom 25 and 95% confidence interval is going to be 2.060. So that is our test statistic. So substituting these values into the formula gives us x1 minus x2, so we're going to have 16.12 minus 19.85 plus or minus. We just found that test statistic at 2.060 on the square root of 3.58 squared over 26 plus 4.51 squared over 26. All that is given in the summary statistics, right? So evaluating that standard deviation, we're going to get, and I'll go ahead and subtract the sample means. I'm going to have negative 3.73 plus or minus 2.060 times 1.12927. And finding the margin of error, we're going to get negative 3.73 plus or minus 2.326. So this gives us an interval from negative 6.056 to negative 1.404. Now if you flipped what we called sample 1, sample 2, that would be positive. It would be 1.404, comma 6.056. So be careful in your interpretation. So what does this mean? So this interval suggests that the mean difference in gas mileage of automatic cars is between 1.404 and 6.056 miles per gallon less than the mean gas mileage of manual cars. Now you could sort of reverse that and Say manual is that much more. Either way is fine. Now let's use a TI to run this calculation and compute this interval. Press Stat, scroll to Test, select to Sample T interval. We're going to input our sample mean, standard deviation, and sample sizes, and select the confidence interval and select Calculate. We get exactly the same interval, -6.001 to -1.459. It's not exactly the same though, is it? It's a little bit different. So I want you to notice what the degrees of freedom are. It's 47.55. And that's what the calculator used, which accounts for the slightly narrower interval. So when doing this on the AP using technology, be sure to name the procedure, to sample T interval, and give the interval and give the degrees of freedom, give the DF. Make sure you select No for pooled. In StatCrunch, go to Stat, T-Stat, to sample, with summary. Enter the summary statistics and uncheck the pool variance box and press Compute. And we get the same thing that we did when we used the TI.